So completing a square is sometimes we need an operation that we need to do whenever we've got a quadratic and it doesn't factor. I've got an x in two places. I've got an x squared and I've got an x not squared, and I wish there was just one x in this expression rather than having the x in two different places. Now I know traditionally when completing the square is taught, there's like an adding and subtracting the same amount. I'm going to do it a different way, a quicker way. What I want to do here is, well, I only want to work on this part of the expression. So I'm only completing the square. This plus 5 here is just hanging on the end, and I'll clean it up later. So this square part is what I'm replacing with bracket squared minus bracket squared. So that bracket squared minus bracket squared, that's the structure that's always there. That's what I start with. And this first bracket has a minus in it. Now, there's only one more thing to fill in. There's only one more question to ask. What's in front of the x? 4. Well, more importantly, plus 4. You split that plus 4 into two pieces, so two equal pieces. Split it in half. Half of it goes there, and I'll put the plus in. Half of it goes there. Now I've completed the square. In this expression, there's only one x. We can clean this up. I mean, plus 2 squared, that's 4. I don't need this square bracket around here. That was just to separate out the piece of algebra I was working on. Oh, and minus 4 and plus 5, that's just plus 1. But that's just cleaning up this, this extra piece that I never touched until the end. Now I have completed the square. The original expression is equal to this expression, but in this expression there's only one x. It's a bracket squared plus some number. All right, why does this even work? And why is it the same as the original way that I was taught when I was in school of adding and subtracting something? Well, let's look at this sort of general expression. Again, I'm ignoring the plus number on the end. I'm just worried about, I've got an expression with an x squared and an x not squared, and I wish there was not an x in two places. I wish there was only an x in one place. The structure is bracket squared minus bracket squared. The first is x, and I take half of what's in front of the x. Well, I put a 2b here, a plus 2b. So half goes here, and half goes here. There, the square is complete. We're done. This is a faster way when completing the square. It's a good way when completing the square is just a small piece of the whole problem. It's just an algebraic step that you're supposed to do quickly. So I can just do this, in one step. Why does this work, though? Square this bracket out. If I take this expression, and I mean x plus b squared, that's the bracket times the bracket. Now let's multiply this out. Foil it out, multiply it out. The x times the x, there's the x squared. X times the b for the inner, x times the b for the outer. So the inner and the outer are the same. That's why it doubles to be 2bx. And the last is the minus b squared. Well, no, is the plus b squared, because whatever sign b is, b times b squared is going to be positive. That's what this minus b squared is here for. Its only job is to get rid of, to cancel out that plus b squared that pops out when I FOIL those two brackets out. So that's why it works. Now there's a couple of things you might ask, and that's in a nutshell. But you might be saying, what happens if this is the plus, but it's a minus in front? Then I split it in two pieces. Half of minus 4 is minus 2, and it's now minus 2 squared. course, minus 2 squared is still 4. Minus 4 plus 5 is still the 1. So if this is a negative, you just still chop it in half. Half goes in the first bracket, half goes in the second bracket. It's bracket squared minus bracket squared. Now you might say, all right, well, this is working out, but what happens if there's a 2 or there's some factor? It's not a 1 in front of the x squared. Well, if there isn't a 1 in front of the x squared, then I'm only completing the square in the piece that has I'm only concentrating on the algebra chunk that has the x squared and the x. Just take the 2 out. Factor the 2 out of that bracket. With the 2 factored out of the bracket, now I've got a 1 x squared. I can complete the square in here. So that's going to be 2 times, now I'm just working inside that square bracket. It's going to be bracket squared minus bracket squared. This plus 11 is just tacked on the end there. Now, the first one has an x. I take what's in front of the lone, the unsquared x is 3. So half of that is, plus 3. So half of that is plus 3 over 2, or 1.5. I put half of that 3 here, half of that 3 here, and half of it here. It is a plus, I'll put the plus in, and now I've completed the square. All that's left to do is clean this up algebraically. So (3 over 2 squared is 9 over 4. So this is going to be 9 over 4 when I square it. And I'm going to multiply the 2 through the square bracket now. 2. So 9 over 4 times 2 is 9 over 2. So now I've multiplied that 2 through. And I want to combine these two numbers together. So I'm going to think of this 11 as, I don't want to think of it as 11, I want to think of it as 22 over 2. So I have 22 over 2 minus 9 over 2. (13 over 2). So there I've completed the square. Is this the same as my original? Yeah, and how would I prove that? You could just expand this all out, multiply it all out, tidy it all up, and you'll get your original expression. So, in a nutshell, what are we doing? If you have a 1 in front of the x squared, it's bracket squared minus bracket squared. You take half of what's in front of the x, half of it goes here, half of it goes here. Pay attention to the sign. Check your work by expanding everything out. That's it.